Hello and welcome to today's Impulse presentation, a series of presentations which cover augmented and virtual reality, 3D virtual meetings and some IoT things. My name is Mark Simpson and I'll be your presenter today. Today's topic is augmented and virtual reality and how we can use this productively in the workplace today. We're primarily concerned with the current developments in the digital transformation of society, where there's a clear trend in companies towards digitisation, automation and networking. Pretty much everything that can be digitised will be digitised. Attempts are being made to automate everything possible. Some efforts, it has to be said, much more useful than others. Trends towards home working and the current restrictions on business travel make the ability to show and discuss products and projects virtually absolutely game-changing. Let's have a quick look at the agenda for today. Are people interested and ready for VR technologies? A very quick look at a few market trends just to set the scene. What types of product interaction can and do they offer us? The meat of the presentation is a lot of real-world examples for AR and VR, applications that we've created for customers and ourselves. And later in the presentation you'll get links to download these applications, test them directly. Let's have a quick look at what A, augmented, and V, virtual reality. Just a quick check that we're all on the same page. Augmented reality, the insertion of virtual objects into the real world. In this case you can see a virtual 3D model with animations playing on our office floor. As the model moves, you lose the view of the wall behind it, and it's very real. You only need to have the thing that you want to see, the object. Compare and contrast that to virtual reality. Here shown as a walk through a factory using an immersive headset that you can see on the left. As surgeon moves his head, you look around. The whole factory is one-on-one. You can jump around. You can actually fly around, which is often a good way to see things more quickly than climbing all the ladders and platforms. The whole thing's one-to-one scale. You can measure, you can attempt to walk through gaps. If it's not big enough, it'll stop you. Virtual reality, a totally virtual world. In 1994, Paul Milgram and Fumio Kishono proposed the Milgram Reality Virtuality Continuum. Boundaries are a bit blurred between virtual and virtual reality, but here's an explanation of what you get. Firstly, actual reality, the real world that we sit in. Augmented reality, where virtual objects blend with the real world. Good examples of this would be Pokemon Go, IKEA Place, put furniture in your living room, the Dulux Visualizer app, change the colours on your wall. Augmented virtuality, which is almost virtual reality, but the data's real from somewhere. Could be live video, could be a virtual model of an engine in a virtual world, but showing numbers coming back from the original. And virtual reality, totally virtual everything. For us, the two key technologies are AR and VR. For VR, you've got to have the model that you want to show and the surroundings model. For AR, you only need the object you want to show. The technology puts it in the place, but only when you be there, so you have to be there to show it. Let's have a look at a little market information for augmented and virtual reality. Is it interesting to people? So Bitkom asked several thousand people, have you heard of AR and VR? Around 90% have heard of VR and a little over 70 AR. So clearly it's kind of well known. When they asked in a little more detail, around 10% owned a headset. Another 22% have tried out a VR headset. We guess this is largely games. And another 21% can imagine using one. More than 50% of people really tried it. When we talked about AR with them, only around 4% knew that they'd downloaded an AR app. Around 13% had tried one. Another 7% had installed them and not tried them. another 25% can imagine doing it. So we can see that more than half the population is already into this. To reinforce people's openness to technological advancement, this is a great example. In the papal election here in 2003, things looked like this. In 2013, one decade later, everyone has a smartphone or tablet in their pocket. The same time frame, the cost for a VR system has changed from 100k plus to perhaps 1k. The pace of technological development goes on incessantly, and the whole thing happens very, very strongly in areas where there's a possible mass consumer market. In 2016, we have Pokemon Go, the first AR game. 2018, showing VR on a headstand with a $1,000 laptop and a headset from Amazon. In 2020, download a CAD model from the web, place it in your car park on the phone in your pocket for free. The smartphone tablet revolution means use of the high-power computer devices are now everywhere, and many more uses of that technology are becoming available. The addition of 4G and cloud computing only increases that trend. For us, this means the acceptance of new technologies is really the norm in society, and especially in industry. Just a little about sales figures in the AR/VR arena. As you can see in 2020, augmented reality apps in end-user devices are still at a low level. But we can also see how the whole thing increases, and according to IDC, we expect that by 2023, the annual sales figures for AR will rise to over 60 million euros, and that the end devices will adjust accordingly. VR-specific devices, mostly used for gaming at the moment, are already at a very significant market level and expected to quadruple in the next 4 years. We take from this that mass adoption of AR/VR will simply be there, and the corresponding number of people will own and use the enabling devices. It'll just be part of everyday life. People use augmented reality technologies more and more in everyday life, and obviously will want to use the same thing in industry. So to sum up, AR and VR are innovative technologies. Lots of people want to try them out just because they can. We stood on stands at trade shows with a tablet showing AR of a customer's equipment placed on the floor, and it's the best way ever to get people to talk to you. Works much better than freebie bags, key rings, chocolate and even free beer. It's also clear to both us and our customers that the use of these new technology greatly increases positive perceptions of your company and has plenty of practical benefits as well. So let's have a look how these new methods for product interaction work. As you've seen, and we'll see a lot more of, we can show your product and projects with AR and VR. You don't need to actually have made the thing yet. So what do you need? For AR, just a model of your project and a smartphone or tablet, with the software of course. For VR, you need the model of the thing you want to showcase, your product, and a virtual environment to show it in. The environment can be a virtual version of the real world, or just something typical or futuristic and cool. Lots of options here. Most of the models come from CAD, and we have great tools to auto-optimize them for AR and VR. We do, however, work sometimes with scanned objects in the real world as well. So the final slide of this introduction needs to cover a little of what technical possibilities there are to work with the real world and your data. These techniques are built into AR/VR apps to give them their specific behaviour in a wide range of combinations. The base software is not from small vendors but from the really big hitters like Google and Apple, who have control of hardware libraries it utilises. We've been doing VR for 30 years on specialist hardware, but now you can do it on the tablet you use to watch telly. The reason for this is that it's now part of everyday life. IKEA Place, Pokemon Go and the Dulux Visualizer app are used by anybody with zero technical knowledge. There are layers of software on top of that provided by Google and Apple, usually a game engine, which make using these techniques hardware agnostic. Unreal and Unity are great application libraries, which by their nature are widely tested on a large range of combinations of hardware. One common technique we use is motion tracking, done with simultaneous localization and mapping, known as SLAM, so that your hardware knows where it is and which way it's pointed. Typically it's a mix of gyroscopes in the device, feature maps from the camera and fast processing. GPS works outside, but it's only good to a metre or two. Not much use for AR. You should be able to set a datum for something in AR, and irrespective of which way you point the device, it shouldn't lose the plot. We use area and plane recognition a lot, detecting floors, walls and flat surfaces, places you put things down maybe, or not to walk through in a VR situation. Picture and 3D object recognition allows us to add special behaviour into the apps, which recognise a label, a picture or a QR code and display some information or start an animation perhaps. Recognising a real-world 3D shape allows us to find the corresponding CAD model and then access any related information for it from a database, from a data sheet, anything you've got. Optical text recognition, reading some text from the camera of the device and doing something with it, allows you to do things like show the maintenance details from equipment tag number, or show part availability for a part number that you can see on a label on the machine. You can use it with a map to update your position in the virtual world as well. User interaction. AR and VR models don't have to be fixed. They can have animation, behaviour and movement. Action to open a door by touching the screen, remove a panel, make something transparent to see what's inside. Immersive behaviour. More of a VR thing really. Put on a headset and things become far more real than looking at the screen. Also, you can reach out and see if you can touch something, as the virtual world tends to be operated at 1-to-1 scale. And finally, multi-user, which we've not spoken about before. Gives a guided tour of a new facility before building it perhaps. Users can wander off from themselves and look around and be called back to a point of interest, like a real demo or factory tour. Safety reviews, product launches, handover meetings can be done with users all over the world using all sorts of hardware, tablets, computers, headsets, without anybody being there. So now let's look at some actual examples of AR and VR applications. The applications will be the delivery across all of these application areas. So on design, we'd expect to see things like virtual design reviews and collaborative meetings, typically VR activities. For sales and marketing, typically product experiences and documentation, tends to be more of an AR thing. Production logistics, human-machine interface, instructions and navigations around a product, remote support, someone over your shoulder looking through your goggles, showing the instructions but also talking to you by ear about where to put that nut and bolt. Great uses for training. You can do all of your training and health and safety stuff, remote group learning before you built the factory. In service, there are a lot of possibilities for very specific devices and straightforward tablet apps to give context-sensitive instructions, visualize work breakdown, and provide remote expert support. Here we're showing a tracking example. Model of an apartment block has been loaded using AR in a car park, shown on a tablet. Expanded to full size when you've loaded it, just because it's convenient. As the user moves around, the model appears to stay still. What's actually happening is that the view of the model on the screen of the tablet is being updated to the movements of the tablet. This is done using SLAM that we talked about, and it tracks perfectly. So the user's moved left, now moves in right, walking past the model. You can actually go all the way round it, up to 30 metres away if you want to. And then you can turn away from the model, from the datum you placed. Look somewhere else, look up, look down, turn back, and the model's just there where it was when you turned your back on it. Perfect description of why tracking is useful. Just to put your apartment block in the car park. This example of tracking is a more industrial one from a customer of ours who was working in a -70 cold store. They planned some designs but needed to check whether it would go in because the cold store can only be reduced in temperature for a very short time. So into the model they built 2 datums, as the thing has several levels in it, and a very simple model of the installation. When they were back in the cold store, next time it was warmed up, They referenced their model using an AR app with the 2 datums in it. We were able to show the new equipment in with the old, despite the fact there's insulation, planks and all sorts around. So they were able to see where their design model would clash with the real world instantly. Little measuring, little problems, irrespective of equipment lying around site. And it's surprisingly realistic. Here is someone putting the hand in between the grey generated model and the original pipework sitting on the floor. Shows it passing through the ceiling. It just works. So tracking can be really useful as a technique within AR applications in particular. This example of area recognition shows something placed on the table. In fact, we've recognised 2 planes, one on the table, one on the floor. It means that we can do hidden line removal as the thing slides backwards and forwards under the table. Another nice use of area recognition. Here we have an example of image recognition. The catalogue code's recognising the catalogue, the image of the engine, loads a 3D model of it onto the screen in AR. Using our i4 Augmented Catalogue app. On a small cloud server, there are image pairs with models. Works on the screen or in a printed catalogue. There's a separate QR code we generate for you that allows you to select which library, so you have to put that on the website or in the catalogue. They're straightforward things and very cost effective. Here's an example of image and object recognition in the real world at a trade show. Our good customer Mariani builds palletizing equipment. It's recognised a QR code and loaded an animated model into the AR app. You can see the actual pallets moving within the app. Here's shown smaller than that, but you can easily blow it up to full scale. Recognise the image, load a model. The model can be animated or fixed. Here's image and object recognition doing far more things. So onto a live running machine we've stuck some QR codes. The QR codes are recognised, a model loaded, superimposed with the real world model. So the animated doors can open, as you see the real ones don't open behind. And the palletizer cassette comes out to clear a jam. So it can be used for inserted documentation. Far smarter than a video because it shows you on the thing. If you want to see the actual wrapper working, it can show you the wrapper mechanism overlaid in AR on the tablet over the top of the real world machine. In this case, it's recognised the object at the end of the wrapper piece. It can also show you how the inside of the wrapper works in an animated manner, positioned by the QR code at the bottom left of the screen. Back to our robot. This is just an animated robot. You saw a little of this one earlier. From a customer's program, it's running a machine sequence which we added to it on top of the CAD model, which is actually a download from a free website. I think FreeCAD, this one, or Turbo Squid. We could make models or series of models play NC machine code, pretty much anything you like. In this case, you can interact with this pump from our customer Klaus Union to show dismantling sequences. Sometimes interactions are keyed by touching parts of the model. Sometimes we can put buttons around the outside of the interface. In this case, they preferred buttons that said take apart, show this view, show that view. They also like sectioned models, this showing how their pump, which contains no contact between the fluid and the bearings, it's a magnetically driven one, works. So we added fluid movement paths. And here you get the same model displayed on a table. So you can show these things anywhere. Detect a plane, add the user to it, add animation. The actual scaling of this has been done with a pinch grip in the manner of any other tablet app. You don't need to explain to people how it works, they just do it. Immersive VR. So Sergey's wearing a headset, and as he looks up, the view alters. With the controllers in his hands, he can move forwards and backwards. You can just see them there in the picture. And he can step outside and pan and move. So you can walk, and within your own personal limits you can move. So this is his view now, which is far more sophisticated than the one that we get from rendering it. Great tool, Immersive VR. This is our virtual review product, where you can simply load an object. In this case it's a factory full of customer equipment, and Sergey's going to do a full walk around. So using the two hand controllers, he can jump to get to himself to different places in the models. You can walk within the length of the cable of the headset, but practically that's not so good in a huge factory, so it's typical to jump, walk, look. If you try to breach something that's solid, you'll get feedback that it won't let you walk past it. You can touch things and dismantle them so that you can hide panels, you can jump around. So Sergey's going to pick this panel off there and hide it so you can see what's inside. These are all customer CAD models loaded into the factory. Nothing that was specially prepared for this example. It's just stuff that we did with a customer to show a piece of factory. And then finally you can go for a fly round. And you can turn off the collision and you can walk through the inside of the machine, should you be so bold. In this case, the user's trying to follow the product path through the machines. Perhaps the biggest example of immersive VR is done with a HoloLens. So here Scott is walking around the car park, looking at a plant model in large scale. The HoloLens has the advantage there's no cables to it, it's a full computer. And it presents a mixture of about 70% virtual world and 30% real world, so you don't fall over things. But you get a real feel for the scale of the model, how long it takes you to walk between pieces. And it's just another way of doing it. So this is really immersive AR because it's mixing the real world and the virtual. Finally, multi-user. So this is a simple example of our VPC product. So you can see it's here operating on multiple clients, and actually can operate on headsets, laptops, web pages, or fully immersive things. Everyone has an avatar inside. Everyone walks around. The user can call them back, and there's a whole separate impulse presentation just on this product. So as you can see, there are a lot of interesting possibilities which can be combined together to form an innovative platform for all of your future enterprises. The list of combinations is endless, more limited by your imagination than the actual technology. So what does it take to get started? You need some hardware. So for VR you need some special hardware for the best impression. A game laptop around €1,000 and a VR headset anywhere from €350 to €3,500. For AI you can do it very well on a modern smartphone or tablet, say from €400 or €500 upwards. They perform very well. You can show your technology on most 1 to 2 year old hardware, but think headset for VR and phone tablet for AR, unless you want to go for a really expensive headset like the HoloLens at $3,000 or $4,000. Most headsets are tethered with a cable until you get to the very expensive ones. Lenovo MR, €300, and Oculus Rift, HTC Vive Pro, about €1,500, are great virtual reality devices. The HoloLens from Microsoft weighs over half a kilo, powered by ARM, and has a battery life of about 3 hours. Really good, but very heavy. The various smart glasses like Google Glasses or the Aristic Z1 are something like a heads-up display. They can either have heads-up display or a text VDU in one corner of your eye line and tend to work best for applications specifically written for them. Often the forward-looking camera is used to relay remote support and audio feedback, the expert remotely watching over his shoulder. and much lighter to wear than a HoloLens in practice. So where do you get the AR and VR data from? To do these things, you really need some 3D data. We continually look at the ways of acquiring both data sets, the objects for both AR and VR, and the environment just for VR. 3D CAD has some challenges. The availability of suitable models. Everyone builds complex design models, not things suitable for AR. If you're not showing the inside, you don't need the polygons to be there. There are scanning technologies, laser scanning, photo model reconstruction, photogrammetry, and it works, but the data quality is not necessarily great, and often there's a lot of manual processing after the time to acquire the data. Externally, for buildings, there's quite a lot of information available from Google Earth and satellite photos, and also from BIM is a new great source of data for AR and VR. Where do we store it all? This depends a little bit on how IP sensitive your information is. So we would say that 3D data can either live in the app, then it's secure, or it can live on the cloud and be called down to the app, which is more flexible. We can add live data from IoT and access via a cloud service all sorts of the information, maintenance information from SAP or maintenance system, and that can push out to AR apps and VR apps directly. So you want to try out an AR solution? I really hope you do now. Have you got a project? There are standard AR apps that we provide with cloud connection. We have standard VR solutions that let you pick your models up, load them and try them. And for those people who want something special, animation, company logo on the splash screen, special behavior, links to your databases, there are custom branded AR VR solution apps. So these are all things you can download, and the QR code will take you to our website to help you download them. There's i4 Augmented Review, an AR viewer for models. It's free for models under 4 megabytes. And you can buy the Pro version for a whole €5 or dollars. That'll handle models up to around 150 megabytes on any reasonable phone or tablet. Available in Apple or Android. Models come out in the OBJ or FBX formats. You can zoom and rotate them, and you can add links, PDFs or videos to your models. You saw earlier our AR catalogue product. So here you can download a copy of our augmented catalogue. The application's free. There's a cloud service which hosts the model image pairs. Typically say from €99 for 3 months and 5 models. You can use it directly in your marketing materials straight away. 3D models will then appear over your images or on the screen. And you can zoom and rotate the models. They're just motionless. If you want to try VR, there's i4 Virtual Review, and you can get a trial direct from our website using the QR code on the left. €159 a month, including updates and support. You need little to start with. Works with a good selection of VR headsets, the HTC ones or the Microsoft Mixed Reality Portal ones. We can import step via a converter. You can zoom, pan, rotate, hide. You can save the project and points of interest. Really simple tool to try VR. Bring your headset from home and go for it. We create custom apps for people, branded with their logo on the splash screen and in the corner if you want it, with specific animations, connections to videos, PDF and custom functions. Typical engagement would be you send us the 3D model, we create a template of the application and discuss it, we animate the models as described, and we can deliver it either direct for download from your website or via the Google Play Store and the iStore. You then own the app. There's no charge for distribution. You just pay for its creation. They can be very cost effective. So what next? Devices are getting smaller and lighter. The battery's more powerful, the processor's faster. Cheaper devices available for the specific tasks like the headset, and a lot more providers of devices. No shortage, as you've seen, of useful areas of application. Now's the right time to go for it. Marketing has to get bolder, and the use of AR VR is an easy way to do it. So talk to us about your ideas for AR and VR. Everyone we speak to has new ideas and combinations of the technologies, and we have the experience and the people to develop them with you. So get started. More information on our website under this presentation, and thank you for your time and attention today.